I want to welcome everyone who's come on already early. We appreciate that. We're going to introduce Richard and Bob here in just a few. As well, we're going to have a poll about this topic. So we're eager to hear from you. And we have a lot of questions. We're not going to be able to get to everybody's question, but we do have some that we're going to call out. So certainly add your questions in the Q&A. Bob and myself will try to field those as best we can. And certainly, if you don't get your question answered, you can always email the whole team at info@rfvenue.com. We're always happy to answer any questions you may have after the webinar. So looks like we're at 12:30 here, guys. So thanks for joining again. And I want to introduce Richard Stockton, an applications engineer and trainer for our venue. We also have Bob Lee, applications engineer for our venue, and we'll be answering your questions in the Q&A. But let's go ahead and kick it off. So Richard, please go ahead and introduce yourself. And after that, I'll introduce the poll so we can get a sense
Okay,
of who has experience with coordination.
gotcha. All right. So, um, I know some of you definitely, I'm here uh, to go over the basics of coordination and looking at the spectrum and how it pertains to using our wireless devices. And I want to make sure that everyone understands it's for all audiences. I realize that a lot of you know this, a lot of you may not, but review is always good. A refresher is needed at every skill level. So my role for our venue is applications engineer, and we answer a lot of questions on how do I tune my microphones, how do I set up my ears, how do I set up my antennas, how do I keep doing this right so I can get bigger and bigger shows under my belt. So um, we have a limited time here, but I'm going to show you a few tools and go over some tools that our venue doesn't make, but it's stuff you'd buy at a hardware store, for example, like little things here and there. Um, this job is definitely about organizing and being on top of things and looking ahead. Uh, so looking at the spectrum with the right tools is key. That's why if you consider yourself an RF coordinator or manager, we can call it several things now because we have networking and systems work involved. So let's say we're called RF managers now, and part of that job is to look ahead at the spectrum and dodge the bullets. So those bullets are TV. TV's noise, unwanted signal. So what I'll do though is I'm going to go over some little things here and there about again why we're here and get into the nitty gritty of coordination using our RF Explorer, using our system builder together. They work very well together, and then I'll go over another program that I use often is Soundbase. There's others out there, of course, IAS and Workbench and WSM and various ones from manufacturers.
Excellent. Let me go ahead and launch that poll, Richard, so we can get some data here.
Okay,
Can you guys see that?
I see it.
Great. Just give it a few minutes and probably around a minute to get the everybody to answer, and then we'll kick it off.
Okay.
All right, great. Looks like 50% of you coordinate frequencies every time. So good for you guys. And for those who don't do it as often, we're interested in your feedback about the webinar today. So Richard, why don't you go ahead and kick it off?
All right. So again, we have a limited time, but I'm gonna jam everything in here that I can. And what you're seeing now, the three areas we're going to focus on, and the first one is the RF Explorer coordination program built into it. Of course, the RF Explorer is a spectrum analyzer tool, but it's packed full of other things that you can use. And one of them is uh, frequency coordination. The others I'll show you once I open up my connection to it. I'll show you a little bit here and there. Um, Wireless System Builder is on our website. It takes you through the same steps as well as RF Explorer, and that is creating your inventory, creating your location, seeing what signals coming in, pulling from a database. In this case, System Builder is pulling the TV station information. Both you can there's hardware profiles for different manufacturers' equipment. In RF Explorer, you can enter your own. It's customized there. The bottom line is you need a spectrum analyzer to see what's going on in your room. You can use all the databases you want, but if you don't physically turn on a spectrum analyzer in your environment, you're just guessing. So the two main tools for an RF engineer is the spectrum analyzer and the coordination tool. Everyone has a different workflow. So all it means is that you practice punching buttons and knowing where to go to. So in my opinion, there's not one better piece of all, this one works the best. It's just whatever fits you. And the cool thing about the RF Explorer, it's super portable, and it does everything that the big ones do. So it came in handy for me when it started to ship, and I'm very happy to have. Well, we do at our venue too with System Builder here, is we can help you get going faster than you can with they say the more complex frequency coordination programs. It's either one you can be fast at, but you have to realize that you simply just want to avoid TV. So however way you get there is fine. Let's talk about more of that subject of what we're avoiding. So we can make our wirelesses successful, and they could act as wired mics. It's just that you got to do the work ahead of time, and you got to be on top of things. That's all it is. And this can be fun. You can put all the time in to do this, and hand the mic off to your talent or whoever it is, and be just as confident. And it is rewarding when everything works. There is that goal is obtainable, no matter how big or small the event is. The feeling of getting a mic that works handed off is awesome. So that's why I keep doing it. All right, radio waves, RF, radio frequencies. It's an electrical component to it. It travels at the speed of light. It still bounces around the room, and that's the trick there, is to figure out, well, how is it bouncing around the room, and what is it interacting with? What's my environment? But the environment comes from TV. It comes from cell towers. It comes from other stuff in my room. So that just means if I can avoid that stuff first and put my antennas away from that, meaning stuff in the room, and point them in the right direction and put them at the right height, I can get this to work very well. The only thing you can't ignore is no matter how the waves are bouncing around, you need to understand how to set up diversity, and how a different antenna may pick up a more constant signal. So, for example, if you look at the pictures here, it's basically saying, hey, sound wave or radio waves bounce around. Your antenna angle matters. If it's vertical or horizontal, that's the difference of how do you mount or position your whip antenna. How do you mount, say, for example, our venue's DFIN. The DFIN is designed to cover both the horizontal and vertical. Then you take it further and you get to this circular polarized antennas. So it's all about grabbing all the angles and making your signal a consistent level. All that doesn't mean anything if you're on top of a TV channel or you have a high noise floor that your signal's on. So the first thing we got to do is figure out what TV is in the area. And if you, for example, if you just have the RF Explorer, you can scan with that and start coordinating. Just get good numbers right away. Or you can use System Builder to pull a database in. You can use Soundbase to pull a database in. Either one, you need to know what's happening. So uh, I would always recommend putting your frequencies on the lowest noise floor. That means it's the spaces, the 6 megahertz spaces where there's no TV. At least start there first. Okay. So I consider in the green here, these are the three uh, pillars that hold the whole thing up. If one of them is not done right, then nothing is, or everything's compromised, like a table, like a three-legged table. So the next thing is, yes, I have to put my antennas in the right place to get the best reception of my transmitters. Check your cables often. You could check your cables with the RF Explorer. You can check your antennas with the RF Explorer. There's different ways to do that. And lastly, we need to make our mics and our IEMs play well together. That means we have to coordinate them correctly. So what happens with transmitters when you energize them and they get close together? The noise floor creeps up because you have interaction between both or multiple transmitters. So what I'm saying is I'll grab some transmitters here. And all I'm saying is that if they're used close together, their harmonics get larger. But if you coordinate in a way that is conservative, those harmonics, those noise peaks, we call them intermods, are lower. So when you're coordinating, there's settings and things you can go into if you really have want to fine tune things, and that's what I'm going to go through today. I'm going to show you with RF Explorer and the coordination built in there versus using a System Builder and then using Soundbase. What the different settings you can use. Now, and lastly, if you can coordinate anything and do it well, but if you don't walk test the products, you're not taking it 100%. Walk test is the true way to say, hey, this microphone plays well in this room when all the other mics are turned on. The building is doing what I thought it would do. So meaning I see what it's made out of, what it's doing to my radio waves. Once you do this often, then you can kind of predict what antennas and what placement works best. And you can kind of be quicker at the front end of things. But a lot of times the best antenna is the most simplest whip antenna. So all this graph is showing you is that if we do things right, we can lower the noise floor. If we use, for example, our stuff, our antennas and distros in the right way, you can lower the noise floor. And especially if you coordinate the right way, you can lower the noise floor based on how your mics and in-ears are working together. So we have, again, the two enemies are noise caused by TV, noise caused by other stuff in the room, and then noise caused by my own transmitters. So I'm going to dive into the RF Explorer. Here's a little bit about it. You can always read up on this. The website has everything on it. But right now I'm going to connect to it. And I'm also going to jump into System Builder. So what I have here, and I'll show you, I have a RF Explorer on my desk. And I have a wired NIC, network interface, that I can have the RF Explorer on my local area network, and I can communicate with it with any of the computers on my network. So on this Mac that I'm using now, if I go to my virtual network controller is remote Ripple. I see the IP address here. Double click, and now I can control the RF Explorer. All right. So just like any tool, you need to get familiar with how to navigate. But basically, what I would do first, and I'm going to show you where to choose what mode you're in, and that's right here. I'm going to go to Spectrum Analyzer mode, which I'm in. I'm going to go to my preset that is a default full spectrum. So let's say 450 megahertz to 650. And if you notice, I have a lot of presets based on, hey, I want to focus on this chunk. I want to bring them in individually. There's reasons why you would bring in multiple sections of the spectrum, but I'm going to load in the full shot right now. I have a transmitter on in my house here, so this is example. Hey, you might see something on that you may not know. It's good to kind of identify that. But when you go into a building to scan, you do make sure that everything's not energized. You go in at night where no one's there and their equipment's off. So you don't wait to grab your scans when people are moving into the room. So another tip there. Okay, so if I want to just save this, I can go to File, Save CSV, and I name it. Let's just call it today's date. And I could ultimately take this CSV file and bring it into System Builder, or bring it into Soundbase, or bring it into Workbench and use it. So it's like a snapshot. Okay, I'm going to go back, but here's all here's everything that the RF Explorer can do. We're just going to touch on the Spectrum Analyzer and mainly the Coordination tab here. Tracking SNA and zero span and power meter, we can all talk about on individually if you like. Just email us. We'll take care of you. So right now I'm going to use RF Explorer for frequency coordination. Click on that. Okay, right now it's launching what I had before. Now what I'm going to do is start a new project. So if I go to Configure and I go to Project, New Project. Okay, it's confirming. And what I do is I set up the name and the span. So let's just generically call this version 1 Rich. And I'm working my way down. My range is now going to be 450 through 650. By the way, at the end of the meeting, I have some documents and stuff I'd like to share based on FCC reports and how to figure out what ranges are good for you, no matter where you live in the world here. So we'll get to that. So I'm setting up my project. I save it, make sure it's saved. Okay, it's there. Okay. Back out. I'm going to create my inventory. And what you do is you start globally. I want to put in whatever I think I may use, but it doesn't mean it's my final list. I just want to enter my choices. So that's global. I just go down the line here and pick whatever out of each. I'll pick like 4 brands here. Sure, Accent Digital at G57 Plus. Okay, let's go to Sennheiser 2000. Cool. Go further down. I got Audio Technica 3000. Electrosonics. Block 21, let's say. So obviously you're given what the show, either the production company or the touring company has. You need to see if it works in your location, meaning what the bands that these are offered in may work better in Los Angeles versus Phoenix and so on. So a lot of times you may have the incorrect band for what you need and you may be squeezing numbers out. Okay. So, okay, once I get that established, I go back to inventory, and my project inventory is what I want to fine tune here. I want to know how many of each that I need. So that's why now it says device 1 through 4. If I want to add one, if I click on the left, it'll say, okay, I want another device, number 5. I hit done, but then I choose here what I want it to be. So if I wanted another 3000, it'd show up. If I the part of this screen is that you go, okay, if I'm going to add two more, then I could do this, click up here, click another line, call it device 6 and 7, or let it populate on its own, and it does it on its own here. And then I can still choose what I want it to be. So when you're entering your inventory, you just got to know where to click and where to hit to in order for it to add up for you. So let's stop it here. 7 devices. Okay, go back. I want to. It takes me to my settings. Okay, normal stuff, display. Okay, the main ones for coordination is how conservative you want to be here. And if you're gonna change your threshold, you need manual control over it. If you want to add exclusions, okay, that's exactly what I want. Now, right here, the third order setting, this is basically telling you to transmit thirds. You have at least 2 transmitters that are going to be really close together. And the perfect example is your in-ears, your rack-mounted in-ear systems. So I'll go back to my PowerPoint. I want to show you what I'm talking about. Our in-ears are always close together. And yes, sometimes you do put spaces in between, but you also have units that are butted up against each other in one RU. So you have to have the third order one on. Fifth order, maybe not so much. When you go beyond the third order setting, you can get, like for example, in Soundbase, you could select 3 transmit thirds. So that's what I do when I do an in-ear rack. I do 3 transmit thirds, third order, and that means when I'm coordinating for something like this, it may give me less numbers, but it's going to give me the ability to have them really close together without producing harmonics. So I'm going to jump to the harmonic slide here real quick. This is just describing when you get items closer together, the transmitters, more stuff pops up. We want to avoid that. The more conservative you are with your coordination, the better you are. But in general, you don't need to be so conservative all the time. That's why the RF Explorer here is set up for a majority of the situations. All right, now I have my inventory. I'm going to start analyzing this. So this takes you to the screen where it reminds you how many devices you have. We're looking at Phoenix here. The best thing about RF Explorer coordination is I can get up and running very quickly without having to rely on an internet connection. That you can do all this with one device. You can be mobile with it. You don't have to be tied to anything. So that's the beauty of this. So my threshold, though, is important. I want to set it to where I do not let the coordination pick anything that's over a noise floor based on where I have it set. So I'll always default to -85, or let's see what it looks like based on my trace. I'm going to go up a bit. Let's try -80. Let's just see what happens. So I'm allowing the coordination program to give me stuff if my noise is underneath this threshold. Now I'm going to hit calculate. Okay, it picked 7 devices, no problem. Let's see where they land though. Okay, now you could take this so what this does, it's picking all the nice spaces, but it may put you on a little bit higher of a noise floor than you may want. So for example, in Phoenix, I know that we do not have good stuff between channels 14 and let's say 22. I'm going to create an exclusion to just block all that out. I'd rather I could go in here and say, well, I don't want this one, this one, this one, and this one, but I'll just block out the whole thing. I'm going to go to my exclusion page. So if I go to project, I double check my range. Okay, good. I'm going to add an exclusion. I know if I don't know where it is, well, I can go from here back to Spectrum Analyzer. Oops, let me go back. I basically need to know what frequency this is, and I can guess by using the scale on the bottom, but I can also go back to uh, spectrum analyzer, use my finger right now. I'm touching the screen of the RF Explorer, and I'm going to make my center frequency 512. I'm going to go back to frequency coordination. Go to project. Make my stop frequency 512. Okay, it looks like it's in there. I'm going to go back. I'm going to recalculate. Now I know it's not going to give me anything there. That's just man. That's my. I recommend kind of narrowing things down, and if you can narrow it down by blocking off certain things, then you're focused more. You might as well see what comes up in the lowest TV channels here. And remember, we're looking at television broadcasting into my environment. This is TV coming in. This is no TV on the air. Okay, I need 7 frequencies. Okay, perfect. This one I might do the same. I might exclude this channel, but I may just get it up and running and see. Maybe I'm just so zoomed out I can't tell what is going on in between there. So I'm not worried about that. I'm just gonna fire things up and start walk testing. So if I wanted to send this to someone, hey, go ahead and use this. I back out. I'm looking at this tab that says report, and that's where I could spit out a PDF. It saves it to the RF Explorer. If I want to go grab it, I would go to System, File Explorer, which has nothing to do with RF Explorer. It's just the name Windows used. Hold on, let me get there again. Okay, Documents. And I go to Date Modified. Here's my file I just made. Then I get that. So right now, my RF Explorer is using the USB port to be on my LAN. I would basically put a thumb drive in, copy it, and send it out. Same thing with the scan I did at the beginning. When I made a CSV, I would grab that file, put it on the thumb drive, and take it to my other whatever computer I wanted to. so like actually you can open up the PDF in our RF Explorer. Here's what it looks like. Hold on. I'm trying to click on it. 1 second. Okay, I'm in RF Explorer. Remember, it's a Windows-based machine. I'm opening up the PDF in it. And this is what you can hand out. Okay, if I want to go back to RF Explorer, I just click on the icon down there and I'm back. So the trick to RF Explorer is to know where to click on the left. You just got to learn it. Mode is kind of where everything starts. So I basically did a coordination with RF Explorer and I tweaked it just a bit just to get going. Okay, now we're going to move on to System Builder. And let's pretend I took that file that CSV file, and I'm now starting a project with System Builder. Okay. Let's just start over. Here's the first page that comes up. So I'm going to do another Phoenix location or building. Let's just do the stadium here. Oops. So you notice the windows start asking you, what inventory do you have? Okay, so you just go through it. I'll pick a few. So these are in-ears. P10T is the model number. G10 is the band. I have 2 units. That means I have 4 channels total because they're duals. I go to Sennheiser. Let's try this one. Remember, when you pick bands, you just got to know, well, what do you have available, and then what's ideal for your environment. You may be able to tell the production company, hey, we should probably use this band instead of this one, depending on what city you're going to. So let's pretend this one is a good one. I have 6. Okay. Let's say someone said, oh, well, a couple more Sures involved. Okay, let's do Accent Digital. I have 4 of those, which means I have 16 channels. G57 Plus. If you notice, G57 Plus goes up here. That's a range I want to talk to you about in a little bit. Keep that in mind. I have G57 Plus. I have 4. That means I have added 16 more channels. Okay, I'm moving along here. The cool thing about System Builder, it can take you through the internet. Hey, if I need more gear, I can have it help me choose which one would work for this event. Right now, I'm gonna just move forward. Okay, here's my working area. I'm gonna organize. Okay, the thing that's missing here is it gives me numbers, but I don't have a exclusion threshold, and I don't have my scan in. So yes, I can get up and running with this based on it avoiding the TV that is pulled from a database. But like I said, if you don't know what's going on in your room, the TV really doesn't. It's not the complete picture, and sometimes the database isn't 100% correct. And you just need to know. You need to visually see. So let's do first the import the scan, and you can navigate to wherever you want. Right here, I have a file in Dropbox that I store for demos like this, and here's a Phoenix one. It's a full scan of the spectrum. Okay. I still have numbers that I would say, hey, I don't want to be in 16. I have some better choices. So Phoenix is definitely 21, 25, and 30. Those are the 3 open ones. So what I'll do is I'll tweak this, and I'm going to put in my threshold to kind of land it where those lowest points are, and then see where it ends up. If you notice, if I go too high or too low, it won't give me what I need. So I'm going to bump it up. See what happens. Okay, it worked for the threshold that I'm using. If I were to go too low, it won't pick anything because there's no one's going to use the threshold this low because there's always noise above it. If I go too high, it's going to give me stuff on a high power TV station. So you have to make that judgment. You don't want to put something on here. So like here, I wouldn't put anything on channel TV 36 in Phoenix. So that's why it's super important to pick that magic sweet spot of your threshold. And ultimately, what gets you 100% signed off on this is when you walk it. You can have a totally clean TV channel, pick a frequency, you walk it in the room, and somehow the reflections just don't like it. So that's how you finalize everything. So I have a complete list. The way the system builder helps you is it pulls a TV database. It lets you import your scan. It lets you fine tune the threshold. and it's all internet based, so you have to have an internet connection for it. Okay, if I want to share this, here's my options: export, copy report link, print, so forth. So if you share it, it usually takes you to your email browser, and that's where you email it from. Okay. Oh, hold on. There it is. All right. Very cool. I would say if you have both in your tools, very cool. A portable spectrum analyzer or a spectrum analyzer of any kind. Really, you got to import your scan. You got to see what's going on. You got to fine tune your threshold. You got to know, hey, if I pick the lowest noise floor, I'm probably better off. Picking the lowest noise floor is your goal because you want your signal to pop out at least 20 dB above that. Okay, here we're going to move on to Soundbase. All right, let me. Oh, 1 second. Okay, so I'm going to pull up. This is a file I've opened, but let's say we're starting from scratch right now. I'm going to pull. I'm going to type in my location at, which is, you already see it, but I'm going to do it anyway. SoFi Stadium. Because the reason I pull this one up is because it shows you that the database isn't always right. You have to import your scan to double check things. So right now, I'm using the online version of Soundbase. There's a paid version too, which means you can obviously do it without an internet connection. So just something to think about. Pull in the database. Take a look. Let me undo this. I'm going to pretend I don't have a scan in there yet. So on my left is my inventory. On the bottom is my spectrum. And on the right is my calculator. And what I want to show you on this is when you do make a very conservative choice, it really helps you with your really tough in-ear racks that you need super long range with. And then you have maybe 12 or more, let's say. Remember, the more you have close together, the more IMD problems you're going to have. The more transmitters you have close together. Okay, so here's Los Angeles. If I zoom out by doing this, I could see the whole spectrum. And here's what I wanted to show you. Here's where 5G is, all the cell phone companies. This is what we don't have to play in anymore. So 615 through 700 is what the FCC auctioned off. We can put stuff up here, but it's really for people with a Part 74 license, which we can talk about offline. Our RFNU can help you get here too. The system builder will help you with stuff up here. But when you're squeezing things out of this whole thing, you have like hundreds of frequencies to deal with. You may have to use these areas ultimately. Here's an interesting thing about Los Angeles. This is Inglewood, but these channels here are reserved for EMS people. You cannot put anything in there, otherwise it interferes with their radio equipment. And the only way you would know that is if you pulled up a database. At least that's the quickest way. So, for example, if you fired up in Inglewood, California, and you had no idea that you weren't supposed to be on these channels, you would have to tune once you start talking to the building personnel. You'd have to get out of here. Okay, so on the left here is my inventory. I'm going to import a scan, and I'm going to do one from Scan Recon. I can go in here and search the area and see who's shared a database or a trace with anyone. And here's one I did last year. This is Insight. So SoFi is actually not it's covered with a roof, but there's the opening, the sides are open. So I consider this a good representation of being outside. I've imported into the program here. Now I can see it. And uh, you notice it doesn't, it pulls up the EMS channels. It pulls up the uh, 5G stuff, and it blocks out what it generally is right. But let's go to VHF2. Another thing you got to remember is that you can use VHF products. They're all the way down here. Let me pull another scan in here. Okay. My scan for LA doesn't have that information, but I wanted to show you that particularly. So let's go back to Phoenix. Okay, so I just went to Phoenix, but now I have the wrong scan in there. So I'm gonna basically pull in uh, one from either from Scan Recon. This will work. I'm just quickly trying to get an idea what's going on here. Okay. Okay, let me get out of this. Tell you what, I'm gonna grab one from what I did, and I'll basically go to my location here. Nope, that's not it. Hey, this is someone else's. Okay, I'll get going. I really want to get to the in-ear thing here. So when I start coordinating, I pick a channel to work in, and I in my case here, 21 or 25. Well, let me get a better one here. Sorry, want it to look better. Okay, 21 and 25 are really good channels in Phoenix. I want, since I have G10s for my in-ears, I'm going to start with the lower frequency because those are the longer wavelengths. I'd rather use longer wavelengths than higher ones if I have the choice. So I go to the right and I check my model number, Shure PSM 1000s, for example. Oops. And G10s. That definitely limits me. I can only go to 541, which is right in here. I'm going to choose 21. So I can create a band plan. Band planning just means you're organizing where you put things, and you start with one channel at a time, let's say. So I'm making channel 21 one of my band plans. Now I could select it. Oh, let me close this. Right here. Here's the key to doing in-ear racks. You need to be super strict with your settings because their transmitters are butted up against each other. The IMD problems are the worst with IMD with in-ears. So I'm going to start with robust. I'm going to put my 3 transmit thirds on. This is the key right here. And remember, this is for when you're doing a whole bunch of in-ears in one rack or at a show. You might need to do this setting. You could do most shows with System Builder and RF Explorer. But when you get to the very tricky ones, like the 100 or more, you might want to consider this setting in general. Okay, let's double check. Robust, 3 transmit thirds. Okay, I want to range. I'm going to shoot for channel 21. Let's see how many I get in there. Okay. This here is telling you what the noise floor is. It's okay. There's if it depends on your trace that you entered, you might get them to show at green, depending on what you have. But this definitely would apply to me. I have all I need for in-ears. I'm going to go ahead and put them over. And now, just to, I won't do everything here, but I just want to show you that if I am going to let go of my grip a bit, well, when do I start doing that? Well, let's consider your microphones. If you have four lead singers that are going to walk close together at one part of the show, well, you might keep the same settings on. Let's say I need 10 wireless channels on the stage. Okay, G57 plus I like to show. I'm going to keep my robust setting on 3 transmit thirds, and I'm going to put my mics in 25. I want to separate them from in-ears. It's just a good practice. So I want to make a band plan for 25. Okay, I'm focused on 25. I'm on 3 transmit thirds, 2 transmit thirds. The fifths are off. I'm on robust. I'm Sure Accent Digital. I want to range. I want to see how many I can get in channel 25. I'm looking for at least 4. 3. Okay. I could sometimes you do it again. It takes another turn to do it. Well, I have 3 transmitters that I can get really close. My next option would be to put that 4th one in channel 30. So I create a band plan for 30. And what I'm doing here is exactly how you're creating a tier of what needs the most work and what needs the least. So my ears and my mics that are going to be really close together are the ones that are going to have the most problems. So I'm going to see if I can just get one more. Okay, I'm going to take that one. And now I can let go of my grip. I'm going to put my 3 transmit thirds on. It's going to make sure I want to do that. And then I can put my setting to standard, and I could use the rest of my mics or whatever that are spread out in the entire spectrum. So that's where you kind of loosen your grip. You go, okay, just put them where I could see, and I get all these choices, and I still pick the ones with the lowest noise floor. But when I hand this list off, I know 100% that all the transmitters that are close together have the most potential to work well. Okay, that's pretty much it on showing you all 3. Just remember the RF Explorer is a really cool tool because it has so much in it, and it's super portable. We can go off on other webinars on all the other features. You definitely can't pack that into this hour. The whole point of this webinar is just to remind you to first of all have the right tools and take the time to look at the spectrum every so often and really learn how to coordinate properly, like really get the numbers maximized. So hopefully I painted a picture for you of that road you got to go down and why we do things differently for in-ears versus mics that are spread out versus, there's other things that are on shows or events that don't need to be coordinated, and that's two-way radios. That's a whole nother discussion. You got to make sure that they don't duplicate numbers, but they're not really coordinated in these programs because they're not all transmitting at the same time. So that's my message for you. Let me just remind you, here's my contact info. 1 second. We can talk about all the stuff we make in more detail about RF venues offerings. Of course, if you haven't tried the DFIN yet, I would really get your hands on one. It's super cool. Plus, we make the CP beam really powerful tools. So don't forget about that. So just email me if you have any more questions, and good luck with everything, and have fun doing this. Your job is to make your client happy, and you can do that. No problem.
Awesome, Richard. Thank you so much for an amazing presentation. And keep in mind, we've recorded this, so we'll be posting this to our webinars page in the coming days. We have a lot of questions. There was a lot of questions submitted, pre-submitted, and we have a lot of good questions that just came in. So I'll start with the questions that just came in. And a lot of them are pertaining to what you were talking about, Richard, so we can kind of double back here. So the first one that came in, is the walk test different from wargaming?
Oh, really good question. There's two different things. So you, I want to show you a picture here, because sometimes when you're wargaming, you really only have a choice to do it nearby. So can you see this picture? So the rack is to the right of me. Everything's fired up, and I start with wargaming. Yeah, you may want to put your transmitters in a worst case scenario, and that means 2 feet from each other, because you visually want to see what happens when you start turning off and on one transmitter at a time. So, so I in this situation, I just said, okay, I'm right by the rack. I'm gonna see what my coordination is doing. I power them all up, and I turn one off at a time, and I go in order. And what I'm looking at on the rack is uh, in this case, this is a quadversity setup, but pretend this is a diversity, and I have 12 channels going. I would turn one off, and if any noise comes in, I would need to reconsider what my choices were, because remember, when one is off and all the others are on and they're that close together, that's the worst case scenario. Your noise and your intermods may pop up in this channel. So a lot of times I'll war game before I walk.
Got it. Great. All right. So the next one may be a little complicated. For a coordination, what RBW and number of points do you use?
Um, okay, let me go to the RF Explorer. So if you notice, if you go to resolution bandwidth, you're really, it's all preference, but sometimes I keep it at a manual setting because I want to have a certain look. But if you go to automatic, and automatic just means you're letting the span, your your view tell you how fast you're gonna sweep and how much the resolution is. So automatic is good too. It just sometimes, like if I pull my preset up that I do with a wide shot, I have the, well, it's in automatic now. I maybe I picked the wrong one. Let me try another one. Here you go. Well, sometimes I thought I did this, but you can have it set to have your RBW set, but just look at the difference between automatic and, let's say, 100 kilohertz. So it is about preference and what you want to import as a trace and how much resolution you want. But when you have more resolution, it slows down the sweep time. So if you want a fast sweep time, say like you're looking at an individual carrier, like if I go to 571.7, which is on now, I'm using my fingers here. And I go in. Well, I could do this. I'm going to create my span at, let's say, 5 megahertz. Oops. Oh, I see. So that's where I have to have it in automatic. If I want to zoom in, I have to take my RBW set to automatic, and it'll do it for me. So that's actually helpful because uh, it's doing the work for you, really. Let me go back. I want my span to be 5 megahertz. Now it's sweeping faster. Hope that answers your question.
Great, great. All right, so here's another one. Can you get a less noisy trace with a VBW setting?
So on my other spectrum analyzers, yes, I tweak that a bit. It's just not always necessary. It depends on your workflow and what you want. But this setting, this automatic versus manual with RBW does help. And yeah, you just deciding what resolution works for you and how you want it to look. That also is relative to how you want your reference levels to look. From zero is your top. Well, you want some headroom to look at your reference level. You just pick what works for you.
Got it. So this question is a follow-up question. One of the attendees asked why you were using a minus 81 threshold. And the follow-up to that was why the decision was made. So he's trying to understand the process of what
Yep.
you were going through when you decided to use minus 81.
It the threshold level determines how what numbers I can get because it allows the calculator to give me numbers what's underneath that. So if I set it wrong or too high, it'll pick something on a higher noise floor than if I set it lower. So it's just finding a sweet spot, really. And it's good because if you don't do that and you just let it spit out numbers, well, you're not in control over the noise floor decision.
Gotcha. Now, this is a really good question that I'm sure everybody wants to know. Why did you say longer wavelengths are preferable for the IEMs? Can you elaborate?
So, yes, when in my experience doing events and things like that, I've had better luck with numbers just based on my decision to go lower in number because the wavelengths are longer, just like sound waves. And if I have the choice, I would always choose that first because I would be able to tell someone, hey, I made a better decision for you. I I'm using a product with longer wavelengths. It doesn't mean that they always walk better, but if you're deciding between higher frequencies with shorter wavelengths and longer with smaller frequencies, well, yeah, try it.
Cool. All right, so this is the one of the last from the questions and answers today.
Mhm.
It's referencing probably the last example using Soundbase. Is this not what the RF Explorer Pro frequency coordination should do by itself?
Yeah, so the RF Explorer, it doesn't pull in a database, which what I'm saying is you can get it up and running without a database because you're seeing what's coming in your room. But you have to remember though, is if you don't get more information, sometimes you may put something on a low power TV station that is not coming through at a certain point, and then someone opens up the door, and now you have stuff come in. There's variables there that you just want to know. If I know what's on the air, then yeah, I know that there's a slimmer chance of me having surprises. So so what I wanted to show you now, so for example, a database coming in, or like if you're in another country, there's a couple of documents that I want to point out, and I can email these to you, but this is a document I found that basically goes over the rules for each country and what's legal. It's a lot of good information. Um, this is a report from the FCC on the status of where we're at now with everything that's going on with new technology that's coming out. It's right here, WMS. Um, just knowing what's active around you is actually helpful in a general sense. You're just more informed.
All right, so I think we have probably time for two more. Obviously, these are very complicated questions with complicated answers. So again, if you want to expand on these, you can email Richard directly, or you can get the whole team at info@rfnu.com. So we're happy to help. Let's hit two more questions, right?
Mhm.
Is the Part 74 license still relevant, knowing that hotels don't care?
I always say yes. Yeah, it may be relaxed a bit, but if you're in a hotel gig that's super complex with wireless, then you can go in the ranges where you may need to, like the ranges around where cell phones are. That it's called the guard band and duplex gap, and there's certain rules for people who don't have a Part 74. That's one of the main reasons to have it. And yes, you can, if you have that license, you can be in charge of your environment. You could say, "Hey, I need you to turn off. I have this license." It generally, in general, though, you don't go to that area. You just work with the hotel staff. You make calls ahead of time, because ultimately, your message to them is, well, I we want each other to have successful events. If you have an event while I'm in your hotel while I'm doing mine, we don't want to make it not work, right? We want to work together. So it's the way you phrase it to them really doesn't mean you're going to always mention the Part 74 thing anyway.
Gotcha. All right. So I think this is the last and probably the best question for everybody. What would be the best recommended troubleshooting process for unexpected RF interference? I think in terms of signal flow, as the rest of us engineers do. So what would be your top ways to troubleshoot problems with interference?
Buy an RF Explorer Pro. Because you have to go find it. So there's many times where stuff pops up. Hey, by the way, I would like to show you. Can I show a couple? Do you have time for a picture?
Yeah, absolutely. We have time. People are hanging with us, so it's all good.
Okay. When you're sitting there watching a show, that's why the spectrum analyzer, along with being on the network with your rack of gear, will alert you of problems. And this is Workbench. When you're getting stepped on by the same frequency, you can't see it in the carrier because it's buried. So if you're looking at your spectrum analyzer, you may not know that there's a problem, and then but once you see this on your system giving you an alert, then you can go ask, hey, turn off our mic. Let's go find that offending frequency, and then you basically take your portal spectrum analyzer and you go find what's out there. The gig I did in Dallas 2 months ago, there were some things that I saw that I had to go sniff out, and I used it because the hotel fired things up, and it was like, well, if I didn't have that spectrum analyzer as portable as it is, um, it would be a lot longer to fix that problem.
Gotcha. Well, I think we've exhausted the time. We want to thank everybody for joining and attending, and certainly, again, hit us up with your questions, and definitely, let us know how we can help. We're also fully willing to hear any feature requests for RF Explorer Pro. We will help mediate that with RF Explorer to add the additional features as that device is
Yes.
firmware upgradable. It's going to be a better device over time with your help and with our help. So we will happily communicate those feature requests for you. Just send it over to info@rfnu.com, and we'll be happy to review it for you and help if we can. So thanks everyone. Thank you, Richard. Thank you, Bob. Thanks, Dawn and Clay, for coming on and helping out. And we're looking forward to seeing you on the next webinar. So if you didn't get a chance if you're busy, you're on the phone, this will be on the webinar webpage in the next couple of days. So thanks again, everyone.
Bye bye.